Hi ladies and gentlemen, today we're going to spend a little bit of time talking about Exit Slip 4, which is the full graphing practice. So it states that a student measures the distance and time data for a bike rider. And make a graph of the following data. Please graph time on the x-axis and distance on the y-axis. Label your axes with units and include an appropriate title and a best fit line. Use a ruler to create your best fit line. So I'm going to scroll down right away. And it tells me that I'm going to be putting time on my x-axis. And the time was measured in seconds. Now I'm not going to write sideways using this, so I'm going to try to write distance over here. I'll just abbreviate it like that. And distance was measured in meters. Now, in terms of your title, what you're going to want to do is develop a title that always has the same general format of y versus x of something. So my title is going to be distance, because that's on my y-axis, versus time of a biker. So far, so good. All right. Next up, what I want to do is try to figure out how I'm going to scale my graph. The graph didn't quite translate over to this document super well, but if you're looking at your graph paper, you should have 14 boxes across and 14 boxes up and down. What I'm seeing is that my largest value for time is 7. And I would take that 7 and divide it by 14. And that would give me 0.5. So each box represents 0.5. So if I start at the first box, that would be 0. 2 boxes later, 1. 2 boxes after that, 2. Now there would be a box here, 3, 4, 5, 6, and then your final box ends with 7. In terms of your other one, distance, you have 60 as your largest value and still a total of 14. And that's going to give you a number that's not so great. It's going to give you a number of 4 point something. That's not so easy, so I'm going to say we're going to take that and we're going to round it up to 5. So each of the boxes on the y-axis is going to represent 5 meters. So I'm going to label after 2 boxes 10, after 2 boxes 20, 2 more boxes 30, 40, 50, 60, and 70 would be your top one. All right. Great. At that point, you've got your axes scaled, your axes are labeled, you've got your title. Now you're ready to make your scatter plot. So you're going to plot your points. I'll change colors here so it's a little bit more evident as to what I'm doing. My first data point is 0, 0. So I've got that. My next data point is time 1.1 and distance 10. So I'm going to go over 1.1. So it's just going to be just after the 1 and up to 10. Next up is time 2.4, so it's going to be halfway between the 2 and the 3. Well, not quite halfway between the 2 and the 3. And I'm going to go up to 20. So right around there. Next up, 3.8 and 30. 4.7 and 40. This is where it's going to be a little tricky with my graph, the way it's looking. 5.9 and 50, and finally 7 and 60. So there we go. There's my scatter plot. Once I do that, I can create a best fit line. That's going to be, I think, pretty tricky with what I'm working with here because there's no ruler, but I'm going to try to just ballpark it. But at this point, I would use my best fit line ruler and I would create that line. Actually, I didn't do so bad. So there's my best fit line. It would be straighter and a little bit neater if I was using an actual ruler rather than just eyeballing it on the computer screen. But after we do that, we're looking to determine the slope of our best fit line. Keep in mind at this point that you don't necessarily have to pick data points. You can pick points that are along your best fit line. So if I'm just taking a look at this, I see this point right here. My best fit line pretty much crosses over at 110. So I'm going to label that 1, 10. And then maybe right around here, I'm going to label that 3.5, 30. According to my best fit line. So this would be my x1, this would be my y1, this would be my x2, and this would be my y2. So what is it going to look like in terms of calculating the slope? Well, my y2 value I just said was 30. My y1 value I said was 10. My x2 value I said was 3.5. My x1 value I said was 1. So I've got 20 divided by 2.5. Now, even though I feel like I'm pretty decent at mental math, I would have to get out my calculator, and I'm just going to do 20 divided by 2.5. And it gives me a value of 8. Now, 8's not enough because it says show your work. Oh, it doesn't say it, but I thought it said calculate the slope with units. One thing that I'm going to want to include on here is my units. So thinking back to what we were doing rise over run. So look back at your y-axis. You were graphing distance in meters on your y-axis. So the meters is the amount of rise. Look at your x-axis. Seconds is the amount of run. So I'm going to say 8 meters for every second. Next up, it says determine the y-intercept of your best fit line. Where does your line intersect the y-axis? Must include a number and a unit. If I'm looking at my yellow best fit line, what I'm seeing right here is that my line, my best fit line, if I had drawn it with a ruler really nicely, it appears that my line would be crossing my y-axis right around 0. Now I'm also going to put meters as my unit because that is important as well. All right, so far so good. My last step is to create my math model. And in order to do that, I'm going to ask myself, what is on my y-axis? So looking back at the graph, I can identify that distance is on my y-axis. I can also identify what's on my x-axis, and time is on my x-axis. In terms of the slope, I already calculated that, so now I'm just putting that in. So I'm going to put it in as 8 meters per second. My y-intercept, I also figured out what that was, and that was 0 meters. So the work that I did here is really important because it carries over to my math model. Hopefully this helps for some of you that are still struggling with how to graph and how to complete every component of a graphing assignment. Thank you.